So the E MOSFET can be biased in the active regions. However, this is a seldom done because it is primary switching the device. Okay. So usually MOSFET, so E MOSFET is biased in ohmic regions. The MOSFET behaves like a register. Okay, that was R sub ds. All right. So it depends on V sub gs. Okay, this is there for the active reasons like this one, V sub gs, 6 ball, 5 ball, 7 ball, it depends, okay? V sub gs more 10 ball here. All right. So this is the ohmic reason, okay, that was active or sometimes saturation reason, okay? So here, the lowest curve of V sub gs in here, 5 volt. That was there's whole voltage to operate a MOSFET. So if V sub gs is less than 5 volt, V sub gs, the Dell's hole, the drain current is approximately 0. Okay. Why? Because below here, that was no current and no inversion layer created. Do you remember here? If they had no V sub G as not enough the V sub GS voltage positive, they could not make an inversion layer to flow drain the current. But they have V sub GS is greater than minimum voltage gate sources, they can create it. Immersion layer means that was the drain current is the operating. Okay. So means the drain current is controlled by the gate voltage. the gate volt. Okay. All right. And for I sub saturations, I sub D saturation, drain saturation formula, we sub DD divided dr sub D. Okay. All right. And usually drain cutoff the voltage is same as supply voltage from the drain. Okay. And also E MOSFET is biased in the ohmic region. That condition should be the satisfied I sub D saturations, I sub D on, while we sub GS, the gate source voltage should be the same, the gate source voltage. But that was the drain curve. I'm not drawing here. V sub GS is equal to V sub GS on, where V sub GS on means like the activated some specific the voltage. So I sub D on is Q test, you know that. And I sub D saturations, that was with sub DD the cutoff. You know, that was formula like this one. It's like this one. That was the Q point is I sub D and V sub DS. Okay. Yeah. Okay. No, not the I sub D. Okay. This is Q. Okay, we're gonna have a sample exam. We'll try to find it. All right. So very simple and sample exam. 4.5 all 0, 0. This is 2, 3. This is maybe N type here. Two and 700, the MOSFET. That was R sub D, 1 kilo ohm. That was V sub DD plus 20 volt. Okay, so now from the table, the MOSFET model 2N7000. From here, we can find the activated V sub GS on 4.5 voltage was given, and I sub D on was given 75 milliamp. Okay. And also from the table, we can see that R sub DS on was 6 ohm. Okay, now that was the given value from the table. Again, I will give you a table, but you have to know the model of the MOSFET and tracking to find it. So, question 1, what is the drain saturation current? What is the drain saturation current? Drain saturation current is V sub ds is what? 0, no voltage for this case. Okay? So we learned before I sub saturations is what? Go back to formula right there. V sub dd divided dr sub d. So V sub dd, the 20 volt, and R sub d, 1 kilo ohm here. Okay, that was the 20 milliamp. 20 milliamp. Okay, now we can simple DC load line, right? Because that was I sub B saturations. That was V sub DS, the cutoff. Cutoff was if I sub D 0, that was V sub DS is equal to 0, right? So now that was the 20 milliamp, and V sub DS is 20 volt. Okay. So the gate source voltage, maybe or the input voltage is the high. The high mean, go back to the graph here. Okay, that was V sub GS, the input here. The high 4.5 voltage. Two and 700 MOSFET that was biased because the conditions is the 20 milliamp I sub D saturations less than what? The I sub D on. So I sub D on, that was the given from the table. Go back to the questions right there. Okay. And also, in bias, E MOSFET is bias in ohmic region. E MOSFET operate as register like this one, R sub ds. So means from this, the original figure like this one, that was for here, we can reuse here V sub dd plus 20 volt. There was R sub d, 1 kilo ohm. So out And the MOSFET, the R sub ds, is 6 ohm. It's a really smaller than the drain register, but you know. So in the for the high input gate voltage, so the V sub out is 6 over 1K plus 6 multiplied 20 volt. That was 0.12 voltage. Okay. Maybe how about the low input? Low input. The gate source voltage. I mean, like this one, that part. 0 volt. For this case, the MOSFET was the open circuit. The open circuit means that part same as the 20 volt. Okay, so the output voltage is pulled up to the supply voltage. Okay. All right. Any questions? Okay. One more sample questions. What is LED current from the figure? So now, same thing, plus the 20 volt, the R sub D is 1 kilo. But we add to the LED, the diode, like this one, okay? The LED diode, 3, right? This is also 2N7000. That was like this one, okay? 0 volt, 0 volt. So that should be V sub in or V sub GS. And we learned before that was drain, gate, oops, and source. Okay, now, so 0 voltage, V sub in, V sub GS, MOSFET, E-MOSFET is the open circuit, means the diode, the LED, no turn on, right? Because no current. Why? Because that was the open circuit, like this one here. Like this one, okay? Okay, like this one. But if they have the input is high, that was R sub ds, V sub out. So V sub dd is 20 volt, R sub d 1 kilo ohm. That was the 6 ohm from the table, okay? Because that was modeled for 2N7000. Oops, like this one. So the LED current is the ohms law 20 volt minus the LED 2 volt divided 1K plus 6 ohm, but approximately we can, but disregard over the 6 ohm here. 1 kilo divided the 18 volt, that was 18 milli, and that is the approximately the answer, like this one. Okay. All right. Okay, what about CMOS? That was, hold on. Okay. CMOS. CMOS complementary MOSFET. Okay. So that was metal oxide semiconductor. Metal oxide semiconductor. Okay. That was same thing. That was really a simple circuit like this one. 1, 2, 3. Okay, now that was P-type. Q sub 1. This is the P-type. And that was 1, 2, 3. The arrow the inside. Okay. This is the Q sub 2. Is the N-type. Okay. And that was place out. All right, so in this circuit, CMOS has the anti-P type, this is the combine. So for example, it depends on the maybe input voltage. Example A, B, C. That was the change sky color. That was V sub DD and 0 volt. So output should be the inversion like this one. Okay. 0 volt with sub DD. Okay. This is oops. A, B, C. So the input 0 volt, the Q sub 1 off, right? On, because there's a P type. And Q sub 2 is off. So the output is for what? This is off mean it's like the V sub dd. However, the input, the V sub dd, just like B here, that was in A, C, that's B. That was different color. The Q sub 1 off and Q sub 2 the on, because that was the high, because the input is high, right? The B type is the high. So but the output is 0 volt. Why? Because the output voltage, the down to the ground. So this is why. Okay. So from here, we're gonna see that the output voltage is inverted. The output voltage is the inverted. So the input voltage is high, is the Q sub 1 is off, and Q sub 2 is the on. Okay. So for this case, shorted the Q sub 2 pull the out voltage down to the ground, right? Okay, one more time. I'm gonna rewriting for you here. Okay, from this circuit, the case 1, the input voltage high, mean the V sub dd. So for this case, the Q sub 1 is off, and Q sub 2 is on. Maybe register or short circuit. Okay, so means